Okay, we can start this one again by doing the angles and subtending the same segment. So if that angle there is 27, then I know this angle x is also 27. So x must be 27 degrees. And then I can use something similar to the one before. I can say, right, if this is a straight line, that's 180. So 3v plus 2v, so 5v is 180 degrees. So 1v must be 180 divided by 5, which is 36. So v must be 36 degrees, in which case this 3v must be 108. And the 2v must be 72. If w will be the same as 3v, so w must be 108. And then y here, we can just say 27 add 108 and take that away from 180, y is 45. And then you can either do the same in the other triangle, or this angle will have to be the same as this angle. So the z and the y are the same, they're both 45 degrees. Okay, for question 8, we're using this angle in the same segment again. So if I look at this angle from D to A is 62, then this angle from D to A must also be 62. That one must be 62. And I could do it the other way around. If this one is 36, then U must also be 36 degrees. They must be the same. If U here is 36 and this is 101, then angle V must be 101 plus 36, so 137. Take away from 180, V must be 43 degrees. If V is 43, W has to be 43, because that angle and that angle will be the same. So W must also be 43 degrees. If W is 43, this whole angle up here must be 62 plus 43, so that's 105. This is a cyclic quadrilateral, so opposite angles add up to 180. So these two will add up to the same. So if that's 105, so take away from 180, these two must add up to 75. So 75 take away 36, x must be 39. And then going between D and E, or D and C, sorry, that's x. So x and y have to be the same, so y is also 39 degrees. Okay, in 9, if this is the centre of the circle, then any line from the centre to edge is a radius. So that's a radius, that's a radius, and that's a radius. So the loads lengths are all the same side. Also notice I tell you that this side with the two lines is the same as this side with the two lines. That means the triangles are basically the same. So W here must be 58 degrees. And then the two angles at the bottom of the triangle are equal. So 180, take away 58, and then divide by 2. Each of those are 61. Y and X must also be 61. And then for Z, you can either do angles in opposite angles of a cyclic quadrilateral or 180. You'd say this one down here is 61, add 61, 122, so the angle opposite must be 58. Or you could say angle at centre is double angle at the edge. So if this one's 2 58ths, 116, Z must just be 58. Okay, again on question 10, we've got a centre. So I know that's a radius, that's a radius, that's a radius. So I know that V and U will be the same size. So if this is 139, U must be 180 minus 139. That's 41 degrees, which means V is also 41 degrees. And then here I know these three angles all together add up to 180. So 102 plus 41 is 143, and then take that away from 180, we get 37. So W has to be 37. And if these are both radiuses, if W is 37, Y must also be 37. Z must be 180 minus 37. So Z must be 143. And then we can work out X by saying if V is 41 and W is 37, and that adds up to 78. Double it to get the one in the middle, X. So the one in the middle, X, is 156. Okay, on question 11, we can use the alternate segment theorem to say if that's a tangent, that's a chord, and this angle, which is 51, must be the same as the angle up here at the top. So B has to be 51 degrees. And then we can say angles on a straight line add up to 180. So that makes that one 66 degrees. And then we can do the alternate segment theorem again. If we do it again, kind of the other way. So we could say this is our tangent. This is the chord this time. So this angle in here is the same as the one out here. So C must be 66 degrees. Okay, and question 12. Alternate segment theorem again says that's a tangent, that's a chord. So if that's 58, this angle up here must also be 58 degrees. The angle we're asked for is O to T to Q. So the angle that we're asked for is actually this angle in here. Put it in red. So if I know that this angle at the top is 58, and these two lines are the same length, so it's an isosceles triangle, I can do 180, take away 58, 122, divide that by 2, each of these angles must be 61 degrees. So that's 61, so this whole angle here must be 61 degrees. This is a radius, and this is a tangent, so I know they meet at 90. So if this is 58, I could say, well, 58, if I do 90, take 58, I get 32. So I know that this one, this little bit in here is 32. But if the whole angle is 61, then this red bit must be 61 take 32, which is 29 degrees. So that angle is 29 degrees.